Class, welcome to today's tutorial, which I will take you through data structures and algorithms. So these are a big unit which will cover it one by one until we accomplish it, and we use it to solve problems which have been solved and which are existing or two. So let us go direct to data structures. Data structures are the programmatic way of storing data so that data can be used efficiently. Almost every enterprise application uses various types of data structures in one way or the other way. So the applications that we use are maybe, let's say an application, let's say WhatsApp. There's a data structure which is used there. So in social media platforms, apps, so the data structure is used. Inside that, we will look the importance and the reasons why they use it. So this tutorial will give you a great understanding on data structures needed to understand the complexity of enterprise level applications and the need of algorithms and data structures. So let us say on why to learn data structures and algorithms, or reasons why you learn data structures and algorithms. So as applications are getting complex and the data rich, there are three common problems that applications face nowadays. We have data search, processor speed, and multiple requests. So what is this data search? Let's consider an inventory of 1 million items of a store. So an inventory is just what a business has. So let's say it's 1 million items in a store. So if the application is to search an item, it has to search an item in 1 million times. So such that it gets 1 million items. So every time slowing down the search. As the data grows, search will become slower, because as the data grows, becomes bigger, the search time will lower down. Okay, so number 2 is the processor speed. Processor speed, although being very high, falls limited if data grows to billion records. So even if the processor speed is very high and the data is in billion records, it will act slow, so it will fall down. We have the multiple requests. Multiple requests is as thousands of users can search data simultaneously on a web server. Even the first server builds while searching the data, because they're coming in bulk, so there are many. So this server will be overstretched. Yeah. So to solve the above mentioned problems, data structures came to rescue. So data structure has come to help to solve such problems. So data can be organized in a data structure in such a way that all items may not be required to be searched, and required data can be searched almost instantly. So that's a big up to data structures. So let's look at the applications of data structure and algorithm. What is it and how the applications go through? Algorithm is a step-by-step procedure which defines a set of instructions to be executed in a certain order to get the desired output. That is the definition of algorithm. So algorithms are generally created independent of underlying languages. That is, an algorithm can be implemented in more than one programming language. From the data structure point of view, following some important categories of algorithms. Categories of algorithms. We have search, sort, insert, update, and delete. What is search? Search algorithm is to search an item in a data structure. What is sort? Sort algorithm is to sort items in a certain order. So there must be a certain order. What is insert? Algorithm to insert an item in data structure. Update is algorithm to update an existing item in a data structure. Delete is algorithm to delete an existing item from a data structure. So as we are going on with the class, we look at the search, sort, insert, and update. We look how to search, how to sort, how to insert, how to update, and how to delete. And it's more important and interesting because it has some procedures, so you cannot start as like that. So we'll look at those procedures and how to deal with each category one by one. Okay, the following computer problems can be solved using data structures. So we have computer problems that can also be solved by data structures. They are as follows: Fibonacci number series, knapsack problem, Tower of Hanoi, all pair shortest path by fraud Warsaw, shortest path by Dijkstra, project featuring data structure and algorithms overview. Data structure is a systematic way to organize data in order to use it efficiently. Following items are foundation terms of data structure. We have interface and implementation. Let us look what is an interface. Interface is such that each data structure has an interface. Interface represents the set of operations that a data structure supports. An interface only provides the list of supported operations, types of parameters they can accept, and return type of these operations. Let us look at the implementation. Implementation provides the internal representation of data structure. Implementation also provides the definition of the algorithms used in the operations of the data structure. We have defined the data structure, so let us look at the characteristics of the data structure. Characteristic number 1 is correctness. What do we mean by the term correctness? Correctness, it means it must be correctly. So data structure implementation should implement its interface correctly. Number 2, we look at time. So the time complexity. Time complexity is the running time or execution time of operation of data structure. So it must be small as possible. Space complexity. Space complexity is the memory usage of data structure operation should be as little as possible. Let us look at the need for data structure. So why do we need this data structure? What is the need? So let us look on it. So as the applications are getting complex and data rich, there are 3 common problems that applications face nowadays. We have looked at them in the above, but we can go through them such that we go together with my notes. Data search, there is processor speed, there is multiple requests. So data search, we said from the above that consider an inventory of 1 million items of a store. If the application is to search an item, it has to search an item in 1 million times. So FL time slowing down the search. As the data grows, search time will become slower. So we need to solve this data search. The problem number 2 is that the processor speed. The processor speed, although being very high, falls limited if the data grows to billion records. So if this data has grown from 1 million times to a billion records, so the processor speed, it will fall down, even if it is fast. So the speed will fall, because it has been accumulated with a lot of work or a lot of tasks. We looked at the multiple requests, and we said that as thousands of users can search data simultaneously on a web server, even the first server fails while researching the data. So it's hard to search the data in multiple requests. Even if the user is failed first, even the first server fails while searching that data. So to solve the above mentioned problems, data structures come to rescue. Data can be organized in a data structure in such a way that all items may not be required to be searched, and required data can be searched almost instantly. So let us look on the execution. Let us look on the basic terminologies in data structure. Terminology number one is data. So what is data? Data are values, all set of values in data structure. Let us look on data item. Data item refers to single unit of values. So it's a single unit of values. Group items. Data items are divided into sub-items called as group items. So group items are the subdivisions of the data item. What are the elementary items? Elementary items are data items that cannot be divided. So they call the elementary items because they cannot be divided. Attribute and entity. An entity is that which contains a certain attribute or properties which may be assigned values. Entity set. Entities of similar attributes form an entity set. What's field? Field is a single elementary unit of information representing an attribute of an entity. Algorithm, a sequence of steps for solving a problem. We have program, sequence of steps that a computer can decode and encode. So there's a difference between algorithm and program. Algorithm is a sequence of steps for solving a problem, while a program is a sequence of steps that a computer can decode and encode. Not that difference. We have a variable. A variable is an identifier for storing a value, or a container storing value in the computer memory. We have algorithm. Algorithm is a procedure that involves performing a dry run on an algorithm to find out if an algorithm works as expected. So as an example, through walkthrough or desk check. I know these terminologies are new, but we look on what's on walkthrough and what is desk check. We have another terminology is record. Record is a collection of field values of a given entity. Walkthrough is performing a dry run as a group. Desk check, performing a dry run as self. Algorithm analysis, process of evaluating an algorithm to estimate its efficiency. Data structure is an arrangement of data inside a computer memory. File is a collection of records, entities in a given entity set. We have the data structures environment setup. So let us look on the local environment setup. So if you still willing to set up your environment for a C programming language, you need the following two tools available on your computer. Number one, you need a text editor. Number two, you need a C compiler. So let's look on what's a text editor. The one you need in this local environment setup. Text editor. This will be used to type your program. Example of few editors include Windows Notepad, Operating System Edit Command, Priv, Epsilon, Emacs, and Vim or V. Let's look on the name and the version of the text editor can vary on different operating systems. For example, Notepad will be used on Windows, and Vim or VI can be used on Windows as well as Linux and Unix. The files you create with your editor are called source files and contain program source code. The source files for C programs are typically named with extension C, the one which is there. That's how it's named. Before starting your programming, make sure you have one text editor in place and you have enough experience to write a computer program. Save it in a file, compile it, and finally execute it. Let's look at the C compiler. The source code written in the source file is the human readable source for your program. So the C compiler, the source code written in the source file is the human readable source for your program. So human must be human readable source in short. It needs to be compiled. So what's compilation? It needs to be compiled or to be run to turn into machine language so that your CPU can actually execute the program as per the given instructions. The C programming language compiler will be used to compile your source code into final executable program. We assume you have the basic knowledge about the programming language compiler. Let's assume. But in my YouTube channel, there is that programs. We assume you have the basic compiler is GNU, C or C++ compiler. Otherwise, you can have a compiler either from HP or Solaris if you have a respective operating system. The following section guides you on how to install the GNU or C or C++ compiler on various operating system. We are mentioning C or C++ together because the GNU and the GCC compiler works for both C and C++ programming language. So we look at how to install C+ or C. So this way, if you have not gone through those tutorials, you go through them, and this is how you are going to install the program C and C++ programming languages in your computer. So installation on Unix or Linux. If you are using Unix or Linux, then check whether the GCC is installed on your system by entering the following command from the command line. You can use a $GCC, then -V as seen in the screen. If you have the GNU compiler installed on your machine, then it should print the message as the following displayed in the screen. So it must, using the built-in specs. So the built-in specs are target configured with the thread model and the GCC version. Key points to note. So if the GCC is not installed, then you go to to their website, which is displayed in the screen. You can use that. So if GCC is not installed, then you will have to install it by yourself by using a detailed instruction available at their website. That's https gcc gnu organization install. You can use that to install it. So this tutorial has been written based on Linux, and all given examples have been compiled on Saint operating system or Saint OS flavor of Linux system. Installation on Mac operating systems. If you use Mac operating system X or Mac OS X, the easiest way to obtain the GCC is to download the Xcode development environment from Apple's website and follow simple installation instructions. Once you have Xcode set up, you will be able to use the GNU compiler for C or C++. So Xcode is currently available at the link which is there in my notes, developer.apple.commercial. This com is commercial technologies tools. Installation on Windows. To install GCC on Windows, you need to install MinGW. To install MinGW, go to the MinGW homepage, the link which has been given there, www.mingw.organization, and follow the link to MinGW download page. Download the latest version of the MinGW installation program, which should be named MinGW. While installing the MinWG, at a minimum, you must install the GCC core, the GCC G++, the binaries, and the MinGW runtime. But you may wish to install more. Add the pin subdirectory of your MinGW installation to your path environment variable, so that you can specify these tools on the command line by using symbol names. When installation is complete, you will be able to learn GCC, G++, AR, downrib, DRR tool, and several other new tools from the Windows command line. In today's class, we are done with the introduction of data structures and algorithms. So in the next class, we are basically going to learn about algorithms and how these algorithms work. Although in the introduction part we have just defined what is algorithm. So there are further steps that we need to look in algorithms and how to write an algorithm, etc. So if you have enjoyed this class, I'd like you to comment in the comment section, like this video, and subscribe to get more updates in the next class. Thank you.